We are still on conversion of temperatures from one thermometric scale to another. In this video, we solve our second example. This question is a very common question in examinations. It is popularly referred to as the faulty thermometer problem. The problem tells us that a faulty thermometer reads -10 degrees at its lower fixed point and 110 degrees at its upper fixed point. We need to determine the exact reading on this faulty instrument when it is immersed in a liquid whose true temperature is 50 degrees Celsius. Following the standard universal formula for our faulty thermometer on the left, our lower fixed point, A, is locked at -10, and our upper fixed point, B, is anchored at 110. The unknown scale value we are solving for, X, will be labeled as T. On our right hand of the screen, the standard Celsius points are clean. Lower fixed point C is 0, upper fixed point D is 100, and the given liquid temperature, Y, sits perfectly at 50 degrees. Let's load these numbers straight into our interpolation formula. On the left side of our equation, we write T minus, bracket open, -10, bracket close, divided by 110 minus, open bracket, -10, bracket close. On the right side, we have 50 minus 0 divided by 100 minus 0. Step 3, simplify our signs and compute our absolute intervals. On the left side, our numerator and denominator contain double negatives. Remember, a minus multiplied by a minus flips into a positive. Therefore, T minus 10 transforms beautifully into T plus 10. Down in the denominator, 110 minus 10 becomes 110 plus 10. Now look at the right side of the system. 50 divided by 100 reduces cleanly to 0.5, or exactly 1/2. Our simplified balance equation stands complete. T plus 10 over 120 equals 1/2. Step 4. To clear the fraction on the left side of our system, we take our fundamental interval of 120 and multiply it across to the right side of the equation. You may also refer to this as cross multiplication. This isolates the expression T plus 10 on the left. Evaluating the right-hand side is straightforward. 1/2 multiplied by our transferred interval of 120 is the same as finding exactly half of 120, which gives us 60. Our equation has collapsed into its final linear state. T plus 10 equals 60. Step 5. To leave our target variable T completely alone on the left, we transfer the positive 10 baseline constant across the equal sign, which changes its operation to a negative. This leaves us with the final calculation. T equals 60 minus 10. Subtracting 10 from 60 gives us an ultimate calculated reading of exactly 50 degrees. Looking back at our examination options, this maps perfectly with option C. Ready for the next question? Let's keep moving. In our next video clip, we will take example 3. See you then.
Udimking Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.